you get 40-50 hits. So if you want to reduce that, you can also filter by using what compound you are expected, so you can get few number of hits then, and then you can look at that for a faster analysis. So this is really good for every crystallographer. That's one more advancement happened. And now the third one is the auto twin indexing. So that means we have got under determine unit cell one more icon or option here. That's after index, you can see there is a domain option, so which will help you to auto detwin your crystal if there is any twin. So it uses like your cell now, which you are doing in a command line. So now it is automatically or by default it is included under domain. So by just clicking domain, you can click on find domains, and then if there is any secondary domain or a twin, it will be able to find it for you. So like how you were doing before. So this is a short video. So you can see I will click where it has clicked on domain, and then you click on the find domains, and then you can see if there is any twin. So it will find the secondary unit cell. And as you know, these unit cell are same. It has a this mother and daughter relationship. So because it cannot be, you cannot have two different unit cells, so you have to have a similar unit cell if it is a twin also, because it's from the same compound. So it's just oriented in different directions, so you can find it easily without using any reciprocal lattice. Of course, manual way is much better. You can separate the twin domains. And Apex 4, you can still separate 8 different domains, and 8 different domains you can be integrated. So, but then if you want to make it faster, and then if you see only 2-3 domains, you can use this domain option to separate them. Okay, that's included in Apex 4. And one more plugin which is completely rewritten is the Reciprocal Lattice, which is now much faster. It's GPU based, so you can load plenty of reflection without slowing down your PC or the Apex 4 software or hanging up of your software. So you can load as much as possible. And then we have got a lot of option under here, edit, view, Q vectors, spinning, plane settings. Under settings, you can change your own settings. Like if you want to use the older version, you can do that. If you want to have a new look, you can have a new look, and you can do all whatever you were doing before, you can do now with much faster and much easier way. And then we have added some other extra functionality for modulated and Q vectors, and so looking at different planes and so on. So you can make use of that. So I will give you a short introduction in this workshop, but then feel free to attend twinning workshop where it will be elaborately shown as well. One more plugin which is completely rewritten is the determine space group plugin. What you were having the options under the expert, so everything you can see now under determine space group plugin, which is now more entertaining and more feedback about your data. So for example, this is the new graph which was not there in the Apex 3. So what is this graph is, it's plotted mean I by sigma versus the resolution. So overall data quality of the data without applying any symmetry. So you can have a clear look like what's the quality of your data, and then you can on the bottom of the screen, you can see how many number of reflection, unique reflection, and overall you don't need to look for some other files to look at those numbers. So you can find it in front of your eyes when you click your determine space group plugin. Also, we have added this periodic table, so which allows you or helps you to quickly pick up those atoms and put it into your formula as well. And then you have a semi-automatic option, like you can use this finish button always, or you can use step by step by using the next and then come back to the previous step as well. It also contains some nice graphics, so or educative graphs, so where you can see about how is your reflection and how it is oriented or aligned in different planes. And you will also get some other graphs like whether how it is primitive lattice, how the B-centered, C-centered, monoclinic, triclinic. So more educative and more graphic now, which will help you to the novice or to the experts as well. And more important, or personally I like very much, is the data statistics you get. So you don't need to look around for the numbers of the important parameters of your crystal, of your data. So you can get what is your resolution, completeness, and R sigma, R int, everything in one table in the under the determine space group plugin. And along with it, you will also get color coding. Like if it is green, so you know it's okay, it's a good data. If it is orange or yellowish, so you know it's a kind of an average data. But then if it is red, so then that's a warning that there is something missing in this data. Please have a look. So that's the advantage or the ready information you get under determine space group plugin. And last but not the least, you have got much more improvement and constantly improved refinement software, that is a Shell. So you know, this software is constantly always getting some improvement. So that's why we always encourage you to download the latest version. So to get all the latest inputs or latest modification in our software. So what are the new features in this Shell XLA software is now, you know, if you have large molecule, if you have 2-3 molecules in the asymmetric unit, so you cannot go and look each name, renaming this atom by clicking on each atom. So now you can do, you make use of this AULA, so that is automatic labeling. So you can label these atoms in a fraction of seconds, or in a few seconds. So you will be able to label all those atoms, and you can label with residues and without residues, which will be helpful while you are doing with the 2 or 3 molecule or 4 molecules in the asymmetric unit. You can do with auto label with residues. And then you have got this contour plots, so where you can create some beautiful pictures to look at your residual density, electron densities, and for presentation or for explaining in a better way. You can also get this now Voronoi polyhedra, which you can create these pictures in for the better understanding of your structure, and then to explain the structure. So you can do that in a Shell XLA software as well. And then you can have these additional softwares which maybe you are familiar or you want to use. So you can give a direct link to Apex 4 under a refinement plugin that you can go under extra, which I will show you later, and then add these programs into our software as well. So by just clicking those software, you can make use of that. And of course, as you had it in Apex 3, so you have this on the fly checks if option. So you can immediately check whether something is wrong in your structure. You have this ideal invariant derived electron density analysis. So the regular structure, you are stopping at independent atom model. So ideal is 2 more clicks so that you can model the bonding electron density and the lone pair electron density, which you can do with Shell XLA now. And then we have also got a DSR, that means disorder structure refinement. So you can do, we have a separate session for that you can attend, but that is also under Shell XLA. You can do this DSR for better handling of your disorder. And one more thing I missed telling you, that we can also, like, you use this automatic HFix, you can automatically fix the hydrogen. If there are some hydrogen missing, so then you can add, click on those atoms, add some hydroxyl group, add some methyl group. So you can also do these things with our with the Shell XLA software now. So which is more useful and then more user friendly now, and much faster now. So please make use of this in the Apex 4 software. Last but not the least, you have got this archiving option. So you can now archive multiple data sets together, and zipping and unzipping and taking out, so that you don't put a lot of data on your main PC. So you can archive that and take it into the different PC, or vice versa. Like you want to unzip and make use of those data back into your PC, so you can also do that. So you can do this in a much faster way by selecting multiple things which was not there before. So you make use of these things as well. So after looking at these things, maybe you are interested to upgrade. So we always want you to upgrade to the latest version. If you have so many options, why don't you upgrade? So that's the best opportunity to upgrade. So it's generally, if you are an Apex 3 user, you can use the same license and it's a free of charge. You can upgrade to the latest version always. If you are interested, after these 3 months, which we have separated now, which we have supplied now for your demo, or for the training. So if you're interested, so you can go and request on the brokersupport.com for the new license, or broker.com. Just go and request for it, and then we will send you the password and login ID for broker support, and then you can download from there. The structure of this Apex 3, or generally the broker software, if you are having a system, diffractometer system, which is controlled by the instrument control server, so which is inside your diffractometer, which is controlled by the measurement server, and then measurement server that's why the measurement server should be running in the background. It also gives you the live update of your system. And then BIS server, which connects between your Apex 4 and the measurement server. This also should be running in the background, and also to run your system. So measurement server and BIS server, BIS is a broker instrument server. These two are running in the background to control your instrument. And then Apex 4 is the only software which user needs for operating the instrument or to process the data. So you can use multiple windows of Apex 4, but at a time only one Apex 4 can be connected to the BIS. If you close Apex 4 also, the measurement will not be stopped, because BIS already taken all of your commands which you once sent to BIS, and then it controls the instrument. So in BIS, you always constantly get the live updates of your system as well. So it tells you about what it is doing, what's the generator, what's the detector, and what's the condition of this. And if you're connected to the cryo system, to our BIS server, so then you will also get update about your low temperature as well, so that you can control switching on, switching off from Apex 4, or you can do multi-temperature data sets as well here in the Apex 4. And then you might be wonder, there is one more software we have got in Bruker system, that is a diffract maintenance. Generally, we use this for service, so maintenance and then alignment or anything we want to do. But if you want to change some default parameters, you can do in bnconfig py file. And also in diffract maintenance, you have an option to change. If you are not happy with the metrics runs, you want to change the metrics runs, so you can do that in diffract maintenance, as long as you know how to do it. I have showed you this, and I want to skip that. Okay, the software, we have already supplied you the software. That's the BN Python, Bruker suite, and Bruker executables. And we have also given you the video where how to install this software. Just keep in mind that you have to install these softwares with administrative right. And then, it's just by clicking next, you will be able to install that software. And very soon we'll be releasing the one-click installer in the probably in the next months or so. You will get that one-click installer. So then you don't need these three different files. So you just click on this, and it automatically installs whole our Apex 4 software or Proteum 3 software. Okay, so we can skip this slide because we have got the video. So if you are a beginner or a first-time user of Apex 4 software, so generally whenever you open the Apex 4, it asks for a username and password. Username is always guest and password is always guest. Okay, so you can it's by default universal for all PCs, unless until you change the password, or unless you change the username. Okay, if you want to do not want your Apex 4 to ask every time whenever you open, what you have to do is you just have to click on the software, right click and go to properties, and make under target, you just put this command, user as guest, password as guest, and say apply, and then okay. So then from next time onwards, it will not ask you any password and username. Overall, Apex 4 looks like this. The window of Apex 4 when you open. So multiple windows can be opened simultaneously in the Apex 4. And on top of the Apex 4, so you get this sample, instrument, windows, and help. Under sample, you get create new, open, archive, import. There are plenty of options, changing the password also. And then under instrument, you can connect to the instrument. You can look at the status of the instrument. And under help, you get the manual. And then if there is a window, so you want to swap between different windows, you can do under the windows. And then you have got a flag here. and then you have got a broker icon here. If you click on broker icon, so it directly drives you to or take you to the brokersupport.com, where you can download the latest software. If you click on this flag, or if the flag is red, so then you know there is a new update available, so you can download. If it is gray, so you are using the latest Apex 4. And then on the left hand side, you can see it follows the Apex 4 follows the natural workflow, which was there in Apex 3 as well, with 7 main plugins: setup, evaluate, collect, and so on. And under each main plugins, you have also got sub plugins to work through your data as well. Okay. If you are interested to change any default parameters, so you can, I already mentioned you can do that in the bnconfig py file. If you don't know how to do it, if you want to do certain things, you can also contact us, or you can edit whatever you want to do, or change the any default settings like font size, like the mounting positions or something. If you want to do, you can do that. I think that's all I wanted to say. I will now give it to Kenchi, so where he will show you the structure now lively.
Okay.
Thanks.
I will share my desktop. Can you see my desktop?
Yeah, I can see. I can see.
Okay. Okay. Welcome to my application science application lab, Yokohama, Japan. In front of me, here is instrument D-Adventure dual source IMUS 3, Mori and Kappa, and Kappa goniometer and photon 3 detector. I will show you structure now, how it works quickly through live demo. Okay. If you click structure now icon here, the first window appear, and you can see this new feature has a sample centering function on this screen. And if you have AGH automatic goniometer head, you can operate the function too. You see this live picture is the adventure here. And if you look at carefully, this instrument has AGH automatic goniometer head in the center of the goniometer. So I will use AGH today. If you wanna use AGH, operate AGH, you choose this tab, motorized tab. Then you can see all functions for AGH. Then you have to click this button, drive goniometer to centering position. If you press this button, you see the goniometer moves to the specific position for centering. If you miss this button first, the centering, sample centering with AGH will go wrong totally. So this button first is very important. Okay. After you confirmed the goniometer is at the centering position, you can press this button, start to click centering. By this button, you can do sample centering by just 2 clicks on this screen. You see, after click this button, it said, please click on the crystal. So I will click one time, and you have to wait a second. Then sample rotate around. Then it says again, please click on the crystal. Then I press the center of sample second time. Then crystal is almost center, but okay. Then if you put 50 microns to move, then okay. Or you can do two quick centering again. A bit off. Maybe I have to tune the instrument a bit. Yeah. Sample is almost centered. Then, when you confirm the sample is on the center of the goniometer, you have to put formula here. Today's sample is standard sample yield. So formula should be carbon 11, hydrogen 10, oxygen 2, sulfur. Then you can specify color of sample here, and you can put the sample size here if you have correct one. If you wanna have sample size, it has equipment here, tools here. You can see this value now 370 micron is the length of green bar. So maybe okay. Then you can specify the sample shape here, and also you can specify the X-ray source or automatic. And by taking frames here, you can use this plugin structure now for only offline analysis by using frames taken already in advance. I will show you this later. Then you can specify the maximum time you can allow for data collection here. And you can specify a resolution also. Then just press start. If you press the start button, you see the goniometer moves to the first position, default position, to start measurement. Okay, generator is now maximum power, 50 kilowatt and 1.4 milliampere. Mori.
You can see at the top that always the feedback is there, starting experiments and so on.
Yeah. Now, frames coming. And you can press take data tab. Then you can confirm the exposure time. The exposure time taken now is 1 second. So I expect 1 minute later, it will provide initial structure. Please wait a minute. And it calculated the modesty of sample is 0.86 degree, and the resolution is fine up to 0.75 angstrom, and unit cell is correctly determined now, 6, 9, 18 angstrom, 90, 90, 90, and crystal system is orthorhombic P. Okay. I think it's just one or 2 minutes from start, and it determines the initial structure correctly. Yeah, this structure is reasonable from the chemical point of view. But structure is solved, but now you see R1 value is a bit higher, 11%, and completeness would be lower, low for the publishing. This is why it keeps running measurements to make all parameter meet criteria for publishing. And if you choose structure tab, you can see this kind of GUI, residuals, frag parameter, redundancy, completeness, R int, R sigma, WR2, R1. Looking at this plots, you can see the status of measurement and analysis now very easily. Okay, and if these all parameters meet criteria for publishing, it will create zip file at the end. So Now we cannot see any report or zip file here. It will take half an hour or so. It's just a matter of time. What you have to do is just wait. So I'd like to quit this measurement now, and I want to show you another way to use this structure now for the offline analysis with the data set already taken. Okay. I have sucrose data, good sucrose data here. So I would like to demonstrate offline analysis with structure now using this data set. Okay. Oh, finish. I have to finish the structure now. Then, then she went to okay. I have created another project for the analysis uh, offline analysis with the sucrose data. Okay, if you take this frames here, this dialog box pop up, and you can choose raw data here. Then you have to put formula here. Sucrose should be carbon 12, hydrogen 22, or 11, something like that. Then start. The algorithm inside in the structure now is same as when you start this plugin from data collection. You see, just a few 10 seconds or 1 minute, it provides the initial structure. Of course, the R1 value is high and completeness slightly low, so it keeps running calculation to meet all parameters for publishing. Yeah. the remaining process would take 10 minutes or 30 minutes or so. So, but that's a matter of time. Okay, that's all for demonstration of structure now from Yokohama laboratory. I would like to hand over to Prasad.
Okay, thanks, Kenji. I hope you can see my screen back again.
Yes. Okay, good.
Okay, and you can also hear me clearly. Okay, thanks. The structure now, the idea is to not to replace the crystallographers or anything, but we want to reduce the crystallographers' work for the routine samples. And also we want to encourage the novice users to make the software much more user-friendly and not here and there or thinking of black box, I don't know what it is doing, or some scared of those things. So we want to make it simple. So that's why the structure now is a very good option. So it also gives you a lot of feedback, as Kenji told. It was showing when he was collecting about how it is collecting, what's the exposure time. You can have the control over the data collection time as well. You can tell structure now finish the data in 1 hour or finish the data up to certain resolution. So you can have a control over there as well. So you don't need to use auto option. You have an option to finish that in 1 hour or 2 hour or 3 hour. Accordingly, structure now adjusts the parameters and then collects the data for you as well. And if you use just auto, so then it tries to get the best possible data for your crystal, and then it does everything by itself and then create a reports. But don't always just blindly look at your structure. The final refinement, we still want you to have a look on the structure, because it's chemistry. You need to know whether the structure now has added all the hydrogens properly and all the hydrogens in the proper positions. So the final steps is still is left to you to work with, and then of course you can create a report and then take it. But the simple structure, most of the time you will not have problem, but make sure that you take care of that the final step. Okay. Thanks, Kenji. So now the next step is I want you to go through with the simple data sets by exploring the other features of Apex 4, which has been added now. So as I told you that as soon as I open the Apex 4, it shows you a welcome screen. It's not an empty gray area now. It has now one window which comes with an welcome screen and what you are doing. So, this was my structure, which I have stopped yesterday at report after showing in the workshop. So that's why it opens here. So I can continue from there, or I can open from the beginning. Or if I, there is a recent 4 or 5 projects I can see already here. So then I can click on those particular thing and then I can just open that project as well. Or if I have to create some new project, so I can use this plus button. If I click on plus button, so then I can create the new sample, either beginning with structure now, or beginning with centering crystal, beginning with the start with sample description, or beginning with the blank project. So whatever you want to do. But right now, I want to make it, I just want to open the project which we have opened yesterday. So I start from the beginning. So I just go to open. So then the structure is open now here. So you just have to go through now the step by step. So Kenji showed you structure now under setup. So now I go to the next step, that is evaluate, determine unit cell. So everything was doing structure now in automatically. Now we have to determine. So I just delete because this was from yesterday still. So you have a semi-automatic option, that is automatic mode, or you have a complete manual option. So what is semi-automatic option is, it will start from, if you're connected to the instrument, collect data, or you can, if you're not connected, you can start from harvest parts and then stop after, even just after harvest or just after index, whatever you prefer. So, or you just want to finish it up and then search and then you want to stop, so you can do that as well. Or if you want to do, just go by step, so you can also do. So for example, I will go step by step. So I can click on harvest. And before that, probably one more thing I wanted to show you. Like if somebody has collected the data, so if you want to know about the information about this data, you click on image header, then you can know what's the data, how it has been collected, what is the exposure time, what's the instrument, what's the wavelength, everything information is here. And there are lots of icons here on the top as well. So you can check out the resolution of your data. You can look at the quality of your reflection. So you can do a lot of stuff here. Okay, so that's will be covered in the other best practices workshop. So we just idea is to go through now the data. So here you can see that you can choose number of runs only one or number of two runs two, and you can also increase the image, maybe more number of frames to include more number of reflection. You can just say harvest. So that means basically what it does is the program is going from one and first and second run and going to pick up 50 frames in each. So from 1 to 50 in first run, 1 to 50 in second run, totally 100 frames. And it's going to pick up the reflection which are having I by sigma higher than 10. And then it harvests those reflections and put it into one empty box here. So you can see I have found 221 reflection. So I can go to index now. So you have three different methods. So the least square method is a kind of a cell now. So you can restrict your search between so and so angstrom to look at each cell, or you can just use the two methods, difference vectors method and fast Fourier transform. So I just click on index. You have got a unit cell. If it is in a very good agreement, you can see out of 221, 215 reflection, it could be indexed better than 97%, so which is quite good. Whereas if it downs to 80 or 70%, so then you know there is some problem with this reflection. So there might be a twin or something. So you can look for the second data as well, or second domain as well. So accept now. The histograms. This will be explained in the next workshop, so you can feel free to attend that. And here you have got a domain option. I just want to quickly show you what is this domain option. If I click on domain, you see this is your primary unit cell. In this case, 99% of the reflection is matching. If it is 70 or 80%, so then you can go and look for what is those 30% reflection, whether it fits to second domain. In this case, there is only one or two reflections, so the second unit cell is not possible, so no domains were found. Otherwise, you just clicking find domains, you will be able to find the second domain, as I showed you in the video. Accept. Now look at the Bravais. It's a monoclinic P. Accept and refine. Okay, it's good data, very good data. So it's having a better fitting of the data. So accept, and then there is a search option. So you can click on search. So it is trying to find hits. You can see now I got a hit in 3 CSD search and no COD, but I have seen 5 hits local CIF and rest, because this I have already done in several times. So that's why there are some files which is there on my PC. So that is why it is showing. So if I click on there, double click, so then it will display the structure. What is the structure and where is the data? You can do that. Or if it is a CSD, if you double click on the CSD, then it guides you to the CCDC database, and then you can already see what is this structure. So this is not the right structure because you can now add the filter, because it's just a organic compound, but at least I know that it is having a copper, so I can put copper. So then it gets the filter out here already. You see, my search has been reduced. So if I click on this CSD now, it shows me exactly the structure which is being published. Okay, it's a copper complex. You can see you got this actually. So this is how simple or how useful it is. So you can use the filter. You can have a database search which is readily available as soon as you get a unit cell. Instead of wasting time further, you can already see whether the data is reported or structure is reported, or whether you have corrected already on your PC. So you can start taking your decision from here itself. Okay, that's the new feature in the Apex 4. So now I just want you to take you through the view reciprocal lattice, which is completely rewritten. So if I click on view reciprocal lattice, you see it will be loading all your reflection which you have harvested now. So you can see this is in the modern version now, which was blue before. Now you got a gray, and then you have also this grid. So which is exactly matching the unit cell, and then reflections are perfectly oriented on this unit cell. And then this is the representation of a unit cell, and all these boxes are representing the unit cell. And if you look at this, how how good it is, how well it is organized. Okay, by using your mouse wheel, you can zoom in and zoom out, and you can have a look at close look at your reflection. You can load millions of reflection. It will not be hanging up or slowing down or so on. So there is no upper limit. You can load any number of reflection. And then by clicking right click on your screen, so you get a shortcut for all the tools. Like you can get brush selection, you can get circle selection, and you can get the lattice selection, you can get the plane selection, you can get the square selection. You can do whatever you want to do. Okay, and then of course you have on the right hand side as well no selection, you can say, or a sphere selection. You can do sphere selection here. You can do plane selection, you can do the plane selection like that. You can use a box selection, you can do that. You can use lattice plane selection. Why do you need lattice plane selection? You want to separate out the twin domains if it is you're using, so you can do that. If you think these lines are too thick, so then you can consider reducing this size of these lines, so that if the reflections are close enough, then you can reduce this line. Or if you want to increase this thickness, you can do that. And then if you want to add some lines apart from this, and then you can go for add planes, or you can say remove planes. So you can do these things in everything was which was you are having in the old reciprocal lattice, you have got now here as well, and with additional features as well. So you have this measuring tool as well, so you can measure the distance between two lattices, and then you can find out already the what is the unit cell length. Or if you want to measure some angle, so you can click on 3 atoms here, and then you get the angle of those unit cell or the reflections as well. Okay, so you have also a brush selection, so you can select like that. And then you have also mouse selection. For example, you want to select one reflection, so you can use mouse selection. And then you have a lattice sections selection, so it completely selects one lattice, and then you can take the other lattice as well. So, and then how you were doing before that, you can lattice plane selection. If you want to move that into different groups, so you can select these things, and then current group to green, and then invert selection, or select to current group. Whatever you want to do, you can do, and vice versa as well. And you can use minimum intensity filter by here, and maximum intensity filter, so you can control your reflection which you want to see. So you can use this intensity filter option as well. And then on the bottom of this, you can group by deselect, select, you can do. And under view option, you can have this crystal coordinates, and you can have periodic modulo coordinates, which will help you to find out modulated incommensurate thing, so which will be explained clearly in the what's a twinning workshop, or twinning and modulated workshop. You can do these things under view option. So I just come back to the lab coordinates, and then you can look at AB plane, AC plane, BC plane, isometric. So however you want to see isometric, however you want to see, you can see along A axis if you want to align B axis, along C axis, along diagonal axis. How does you want to see, you can do. You can also move to the center of mass, the gravity, and you can also rotate along X, rotate along Z, rotate along Y, and stop rotation, you can see. And then you can also control rotation speeds. And if you want to see the reflection in different shapes, you can do that. Squares you can do, circles you can do, spheres you can do, perspective spheres you can do, whatever you want to do. And then you can change, increase or decrease the size of your reflection, because if the reflections are too close enough, you might want to consider separating this reflection by size, changing the reflection size. And zoom also you can control by here. Okay, apart from mouse wheel, you can also do it from view option. And then if you do not want to see these grids, which is maybe some people don't like it, so you want to hide this grid, you can do that. Or if you want to show, you can also see this grid as well. And then you can define the q vectors if you use a periodic modulo coordinates. So you can define q vectors and then do a incommensurate studies and or commensurate studies, whatever you want to do. And under twinning, you can also create separate twin domains and so on. Create virtual cell. You can see you can have this cell and then rotate, so which will be clearly explained in the twinning workshop as well. And you can also control those virtual cell as well. And then you have a separate option like plane. You can look at different planes, HK, KL, HL, show or hide, whatever you want to do. Okay. And then you want to see what else, settings. If you want to change anything, you can also change your settings. So you want to have a vintage look, so you can have the vintage look. You can have a different coordinate system. You have a lot of control, or color change or anything. So you have the option under settings as well. So much more advanced, much more features added to Weave Reciprocal Lattice, and which is GPU based, which is much faster as well. Okay. So this is just an introduction I wanted to take you. So I just want to quickly move to the next one. That is, we want to integrate this data. And already I start integration. In integration, you can also control the number of images. If there is some frames which is affected, so you can control these things. Means you can you may not need to integrate those things. Or at the same time, you can also give the resolution limit for each run as well, which was there in the last version of Apex 3, but Apex 4, it's by default, it will be there. And then you can have a look at under setup the integration. So integration is going on. I think now I have 1 or 2 minutes. Still the integration gets over. So if you have any questions, so I can take it. So let's have a look. Okay, no, I can't see any questions. So feel free to ask any questions. Okay, I can see something come up. Okay. So no problem. Okay, the integration is finished, which will be explained in the next workshop. That is best practices. So if you are interested to know detail about the integration and scaling, so attend the next workshop. Okay. So, and then I'll quickly move to the scale, because these are all same thing what we have done in Apex 3. So I will use just a finish option to make it faster. Okay, so because all step, everything it does automatically now, I don't need to click on each step, and there are plenty of graphs to look at or diagnose your data, which will be shown in the next workshop as well. So now examine data and the determine space group. And this plugin is also completely rewritten, as you can see visibly now. As soon as you load this determine space group plugin, you can see this, I by sigma statistics for your data against the resolution. So it tells you about your quality of your data without applying any symmetry. And then it also gives you what is your HKL maximum and what is the total number of reflection in your data, how much are unique, what is your redundancy of your data, what's the maximum resolution of your data, and some R int and R sigma statistics given here as well. You also get this periodic table now, so that you can add elements directly from your periodic table. If you have missed something, so you can do that as well. And then you can click on next, or finish button is there to make life faster. Okay, what's that? Okay, there is something happened in my data. So let's have a look. Okay. So start again. Okay, I'm using the right file. Okay. Okay, good. So now in the Apex 3, you are having only these things. So now you can see there is one educational tool. So that is, this is in monoclinic and primitive lattice. Primitive lattice means atoms are sitting at the corner, so which is useful for the novice users. And then if you want to change from monoclinic to triclinic, like as you do it in XPrep, so you can lower the threshold here if you make it 0 and repeat. So then you get the lower symmetry as well. So if you want to use, you can use that, or if you want to retain the unit cell, you can retain the unit cell as well. But based on these parameters, you can see that it's clearly a monoclinic crystal system with RSIM is around 0.02, which is quite good. Click on next. And here you can see this is a monoclinic P21 by C space group based on the systematic objects. And then if you want to change, you have an option here for space group. So you get all 230 space groups here. So you can force whatever the space group for your data. And here it gives you the E square minus 1 statistics, where it will show you whether it is close to centrosymmetric or non-centrosymmetric. For example, this data is 0.930, close to 0.968. So that is, it is centrosymmetric. If it is close to 0.75, so then you know it's a non-centrosymmetric. If it is around 0.5 or 0.4, so then you know there is something internal twin is happening. So you need to look at that data. And here there is a weaving tool for your reflection in different planes, HKI, HIL, and IKL. How is your reflection? You can also look at in different resolution and different planes, so that how is your reflection collected in your data. And then you can also, again, I told you that you can reduce the threshold here again and look for different space group if it is possible. Feel free to do it and explore yourself. Click on next. When I clicked on next, you generally get the HKL statistics up till RINT and R sigma. But we have now added in the Apex 4 RRIM, RPIM, and then CC half. So if you're interested in these parameters, generally the protein people are, so you can get these readily information available. If you are a number person, you can just look at these tables properly for each resolution cell. If you are a graph person, so then there is the right hand side, you have the graph. Corresponding graphs is given here. Okay, so all these numbers plotted against the resolution in graphs. And then the best thing is you get the summary of overall of your data with the highlighting the important parameters of your data. So for example, the completeness, redundancy, RINT and R sigma, it's given here, and with color coding. So if it is green, it is good. If it is orange or yellow, you are at the borderline. If you are in red, so you need to address this. So you can do that. And if you want to cut off this resolution, then you can use here cutoff. Basically, you will not be cutting off the data, but for the parameter to look at your data, so you can use these filters. And then you can also use this merging statistics with different options. You can merge the Friedel equivalents, but if you do not want to merge Friedel opposites, you can do those things just here. But this is a centrosymmetric, so it doesn't make any difference. So I'll keep it as it is. Then click on next. So on the left hand side, you get now the INS file, which was only coming last time. So in the Apex 3, in the Apex 4, you get unit cell information here with what is a crystal system, Lavey group, space group. And also if there is any transformation matrix applied, which will be displayed here. And then it comes with the data statistics table and then general information table as well. So here, sometimes the Z numbers are overestimated. That's mainly because you have not given the formula properly. If you have given the formula properly, it also gives you the right Z values. And if there is any warning related to your data, it will be mentioned here, like mentioning poor data quality or poor completeness, check redundancy, something like this, high R internal. So it will mention, or it will write here. So it's more informative and more useful now. Now I just want to go to next step, that is find structure. Either I can use solve structure or the auto structure. I will use solve structure because auto structure you can do by yourself. And we still have these 4 methods intact: intrinsic phasing, direct, dual space, and Patterson. But as you know, intrinsic phasing is the most widely used. And if you have a relatively good data or reasonably okay data, so then you should be able to get the structure like this. Okay, even the atom assigned also properly. Of course, not always 100%, and then you can get close to 100%. And then you can see there is a 3 rest file which has been created in 3 corresponding space group, P21 by C, P21 and PC. So if you put this right space group, or if wherever you want to solve, so I will put that one and then go to the refined structure. So then it takes me to this refined structure. It loads me the corresponding rest file. If you want to load the another rest file, you can use this option here and go to open, and then you have corresponding b.res, which is in P21, c.res, that is which is in PC. So you can load whatever you want, but now I know this is a space group P21 by C. I chose this, I use this. So there are lots of icons on top of this. Let me make it better. So these icon actually corresponds to the, if you put your cursor, so it tells you what it actually does. Okay. So you should not be looking around. So everything is written here. You just have to put your cursor on those icons. It tells you what it does. So learning is pretty easy here. And then the first thing what you want to do, you want to actually assign the atom properly. So I go to the rename mode, and I know this is nitrogen. And then I know this is carbon. Okay. So now labeled properly. So what's the new feature in Apex 4? So if you look at the labeling now, it is randomly labeled. It's not labeled properly. So now what I can do is I can make use of this new option, AULA, or automatic labeling, and I can rename just by one click. So if I click auto labeling, I get an option here. Should I label with residues or without residues? So with residues, I will use if I have a 2 or 3 molecules in the asymmetric unit, so that I will maintain a consistency in labeling without looking around manually labeling, which might take 10 minutes or 20 minutes depending on the number of atoms. So it just does it in few seconds. And then if it is only one molecule, I will use auto label without residues. So only one molecule, so I can name in any number of atoms. So it's quite useful when your structures are getting larger and larger, and different number of asymmetric unit present in your crystal system. So very useful tool. So I like it very much. You can see I just click, in fraction of a second, it labeled all 17 atoms. Not only it is labeling, it also puts your file in a very, very organized way. So just want to just get rid of this. Want to make this slightly smaller. Okay, you can look, this is your INS file. You see, it's also puts all the atoms also in the proper way. So very organized and very well, put together all the atoms. So I just make it slightly smaller, and then we know the steps of refinement. First is isotropic refinement. So you can use this simple. For isotropic refinement, I am with 9% R factor, with around 1.59 is my residual density. If I load refinement results, so it loads the refined files, and you can see now the Q peaks are coming, that is the residual peaks. Just get rid of the labels. And then you can see the Q peaks are coming, and then it is showing you what is not done or where it is. If you want to see where only Q1s, so you can see, okay, Q1 and Q2 is coming near copper, because I have not done anisotropic refinement. By using this, right side colored bar, you can control your number of Q peaks you want to see on the images here. So then you can do anisotropic refinement. I'm down to 4.5%, with the highest peak is around 0.6. If I load, so then it is showing now the residual peaks, which are now indicating the hydrogens are missing. Hydrogens should be added. It's pretty clear from this graph or the picture that the Q peaks are showing the hydrogens. Shortcut shell X, automatic edge fix. So I have added the hydrogens and then refine it. Look at this. I have down to 3% R factor. with highest peak around 0.24. So that basically means I have taken care of all the Q peaks and then or the residual densities. If I have to look at where is my Q1, so you can see I can also zoom in this structure. So it's coming near bond. So that means there is nothing left in this electron density and which is lower than 0.3 as well. So no atom left, everything I have taken care, everything is proper. So I can finish the refinement by just doing updating the weight refinement. That's also just under one click. Select, try to refine until weight converges. You see it refines 10 cycles. If it converges, it converges. Within 3 runs, it is converged. If it is not converged, it will stop after 10 cycles. I can load, so I can look at the refinement history on the right hand side. You can see that the R value is around 2.93. So I have reduced R value is down, and then I have also got full structure refined properly. So now final thing what I want to do, I want to create CIF file, select, insert ACTA and run Excel. When I created this CIF file, the ACTA is the command that is all get straight away from here. That's quick and faster. And then there is one warning. It says cell contents from atom list or unit instruction do not agree. So basically what does this mean is these numbers are not matching with the total number of atoms present here. Then how to make that? Previously you need to calculate and write it here, but now it's pretty easy. Select, update unit instruction. Then you just refine it. See the alert has gone as well. Okay, and structure is finalized. And just want to see that, okay, there is no major alert or anything. I have a fly check CIF here itself in the select layer. I click on, and then you can have a look here, check CIF, the plot on check CIF, and there is no alert. And you know these 3 alerts is because of the reflections which is present in PCF file. The information I need to put that in the CIF file. That's all. You don't have any alerts. So structure is finalized, structure is refined properly. So additionally, in in here in the select layer, you also can create some contour maps, Voronoi polyhedra and something. For that, what you have to do, you have to create some map contour plots. How to create? First of all, you need to use this calculate maps option with the list 6 command. I just refine it once. I refined, so get rid of the Q peak. So what I will do is now polyhedra contour map. How I have to do is I just have to press control and select 3 atoms on the molecule. I selected these 3 atoms. As soon as I select, you can see this icon has come up. This is the contour map icon. So if I click on this icon, so it tells you about how you can create the contour maps. So I go here, the step size smaller, 001, and then I click on the uniform contours. I get the, and then I will change the height scale, probably up to 5. And then I will say, okay. So then I get this contour map. It's looking only black, blue and red. So if you want to have a better, so then I can go under view, create a contour plot in rainbow colors, and then why not? Yes, now you can see your heat map. So for better explaining somebody about your structure, you can create or to show a presentation. So you can create these kind of contour maps and nicely, which is the additional features in Apex 4. So if you want to get rid, you can just click on this icon. It has gone. Okay, that's how you create a contour map. You can also create a Voronoi polyhedra. How to do that is you have to click on the atom, particular atom, for example, this copper atom, and then you can right click on that and draw Voronoi polyhedra, and then you can see, you can get this Voronoi polyhedra map as well. So you can do these things in Apex 4 now. You can create contour map, you can create a Voronoi polyhedra, and you can also, if some hydrogen is missing, you can click on particular atom, and then you can add here whatever it's a hydroxyl group or a methyl group. So it comes up here, and then you can add. In this case, it's nothing is missed, so you have no need to worry. Finally, once your structure is finalized and you have created some map, so you can also add some external program, like as I did it here, Mercury, Diamond, Platon, Pore, and if you want to do anything, you can add. It will be available in our Apex 4. You just have to click. How to do that is, you just have to go to Extra, Add or Remove Program, and then here you can, if you have Mercury, just download from the internet, install on your PC, and just give the path by just browsing here, and then just say add program and start the test, add program. So then it adds the program, and then you can directly use this Platon, Diamond, whatever the program you feel like, Vesta or whatever you want to use. So you can add directly into our Apex 4 software as well, and Power images and so on. So, and then that's almost I wanted to show you with the Apex 4. And I also want to show one more thing is, I have opened already here that you have now the face indexing, which is also much more improved now in the Apex 4 now. So here you have got, I have already collected some video. You can see that this layout has been completely now rewritten. And then this is a dial to rotate your crystal. And then if you see this is too dark, you want to change the contrast and brightness, you can do that here. See, it's looking better now. You can do some brightness correction. You can do sharpness. So you can do gamma corrections as well, okay, for a better viewing. So you can see. And also, not only that, that it gives now maximum Miller index. You can do those things, increase, and then you can immediately start doing face indexing. Much faster, much better way, much quicker. So whatever you see. So there is a vast improvement or very nice improvement even in the camera or viewing option, which will help immensely to look at your face index, your crystal in a much better way. You can also zoom in that crystal if it is too small to look at, and then you can just rotate and see whether you have done the things properly or not. Okay. And then you have these faces coming up. If you have wrongly indexed some face, you have to remove invisible faces as well. So now you see. Okay, I have just done it just to show you on a roughly basis, so you can be mastering this. Okay, you can do it by yourself. How many faces you can see, and how until unless you satisfy yourself, you can do that. Okay, so you can constantly improve by rotating this face indexing. Okay, so if I just want to show one more thing is, I forgot to show you the report. So you have this report option, just one click after the final refinement, and just click on generate report. And then it writes an HTML report for you with all the information, how you have collected the data and how you have processed your data. And along with that, it also gives you, the molecular diagram and then packing diagram here. You can see, you can also have 222, 333, whatever you want. And then you have this regular crystallographic table, detailed crystallographic table, atomic coordinates, bond lengths, bond angles, and then anisotropic parameters of your atoms, and then hydrogen bond coordinates. Everything is written here well clearly. And then if you want to add specific atoms, you can add specific bond length, you can highlight specific bond angles, you can do. You can also add author names and author list, and then you can also import the miscellaneous. So you can import the PCF file here to get the information about your diffractometer, and that should be added to your report or to your CIF. So that can be done by importing the PCF file. But make sure the PCF file is not edited. So whatever the diffractometer you are using or whatever the detector you are using, please mention correctly. Okay. So because it might be still showing Apex 2 CCD, but you are using Photon 3 CCD. The data has been collected in Photon 3 but it might be showing still Apex 2 CCD. So make sure you are mentioning those names properly in your CIF file. So I can just go here under report, and then you can save report. It will be saved under your directory, directly under the report. So under report, you get this CIF file, HTML file that you can just open it and then print it as a PDF and take it for discussion or take it for your thesis or for submitting your paper. So all information without your intervention you can do, or you can do it fast way, but because previously you need to find out or create your table, everything by yourself, but now everything is available ready. Okay, so that's all I wanted to show you in this 1.5 hour workshop. So I am here for next 4 minutes. I can see some questions, so I can take some question. The numerical plus works used to. Okay, so yeah, Kenji has already replied. So let us know if you have still some question. Feel free to ask in the next 3 minutes. We are here. And if you are shy and if you want to ask later, so you can write us an email and let us know if you find it, how you find it. And we are recording this session, so it will be up sometime pretty soon, and then which will be handed over to you, or probably will be put up on some website. So you can always watch. But we encourage you to practice yourself because we have provided enough data. So let me just bring that up. Okay, you can still see my screen, right? So I have sent you the link for this workshop with which gives you access for this all these directories, which contains your Brooker softwares, Brooker suite, Brooker executables, B and Python. With these 3 softwares you need to install. Along with you have a license. So along with that, we have also put up the video so that you can watch this video to how to install the software. Okay, and then there is a workshop disorder refinement, workshop best practice, workshop getting started. So everything has the data inside. For example, this is the workshop we have conducted. You can look at here. There are plenty of data sets we have put in, so you can work and practice yourself. Like for example, I have gone through this data now, and Kenji has gone through sucrose. So still you have got 3 data sets to work with and play around and try to reproduce the results and feel comfortable. If you, unless until you work, it will not come. So make sure you practice. Okay. Thank you. Thank you so much. Yeah, excellent software. So thanks for joining this workshop. And we appreciate very much, and we encourage you to attend the next workshop. It starts in 20 minutes from now. That's the best practice. And if you are interested in twinning, so Kinchi will be giving twinning and modulation, and I will be giving on the best practice along with Carson. And I think there is a couple of protein workshop running parallelly as well. So feel free to attend whatever you feel. So otherwise, I will see you in 20 minutes in best practice session. Thank you, Kenji, for joining in for this workshop and showing structure now. Much appreciated. Thank you. Thanks, one and all.
Thank you very much.
Thank you. Okay, there is a question before I go. Can you share this, please, on following emails? Workshop files. Okay, you have received. Okay, great. If you have not received, so just let us know. You will get this. Okay. Thank you. Thank you. See you in 15 minutes.